Hey, this is Lab 3, Induction Sensors. So an induction sensor is basically a sensor that detects a metal object passing by, and you can trigger things based off of whatever passes by. In our case, we're using a PLC, so we can automate the output from the sensor to other things. So these applications can be used in, for example, a conveyor belt carrying a part down, and that part trips a sensor. So we're going to be simulating that today, except it's going to have the user be pressing a start button to begin the process, and then the part will be carried down to the induction sensor. Sensor will trip when the part passes by it, and it will stop the whole process. And then the user has to go and press the reset button, and then the process can begin again. Let's see how it's laid out. Hey, this is Austin. This is lab number 3 for PLCs. So this is just a rough sketch showing our circuit layout. Up towards the top of the page, we have our power coming in to that bus bar. The bus bar is divided in half. Half of it connects to the PLC. The other half connects is our common lines. So on the PLC in the lower left, the inputs are the X series. So X1 and X2 are our input buttons, and they return on the common line and via the bus bar. X3 is an inductive sensor, so this should detect metal objects when it passes, and then it should send all that to the outputs, which are the Y1s and Y2s on the PLC. And the outputs in this circuit are two lights over there, and everything returns to the common to complete the circuit. So in a second, we're going to go look at our program, see how everything works out, and we'll roll it. Okay, so this is a screenshot of our ladder logic program that we programmed into the PLC, and you'll see our inputs labeled the X's and a C. As mentioned in the sketch before, the X's are our inputs, and those are all be hugging the left side of the screen. On the right side of the screen, under column AF, is our outputs. Those also have different commands set with them. You can see some of them say like set and reset and end. The light blue indicates that that particular component is active. So at the time the screenshot was taken, it's right at the top of the program, ready to start the process. So one thing we're going to talk about before we start our program is the use of a memory bit. In our screenshot over here, it's labeled fault right up there. And what this is, it's a value that you can change and it will store the PLC. So it's also binary. It can go up to a 1 or a 0 state. And we use that value, we can change at will as an output on rung number 2 from the induction sensor. So triggering the induction sensor, which is an input, that will set the memory bit labeled fault as a 1. And then further on down the ladder, on rungs number 3 and 4, you see we use that stored memory bit as an input to change other things as well.
This is a little screen of our program over here. So right now on run is the start button. We're going to try hit it. So when Todd presses it over here, it turns on our green light. Try press it. And as you can see, it actuates. The fault right over here is already closed, so it allows the output, which is the green light, to turn on. Okay, so our sensor is wired up backwards. It's normally closed, so that's what the state is right now. The output of it is a bit, a set bit. So right now that's at 0, but when we trigger the sensor, it triggers and sets the bit to a binary state of 1. And because of that, these other two fault inputs over here, they are now active, and the output is it resets the green light, which of course the green light's off, and the other output is the red light is now outputted as high, which it is right there. Okay, so now the last part is our reset lines 5 and 6 here. So line 5, the reset, it goes to it resets the fault, the bit back to 0. And then line 6, the reset for that one, resets the green light back to 0. So Todd will demonstrate. Alright, and that sets it back to 0. And everything is ready to go again. Alright.